Data structures are classified into two types: primitive data structures and non-primitive data structures. These primitive data structures can be defined as built-in data types like float, integers, pointers, etc. The non-primitive data structures can be said as non-built-in data types as lists, arrays, etc. These non-primitive data structures, lists, can be further divided into two types: linear and non-linear. This non-linear is divided into trees and graphs. A tree is a non-linear data type. A tree is a data structure are used to store information in a hierarchical order. Each record in a tree is called node. The topmost node, which has no parent, is called root node, and each node has either no child or one or more child. And a node which has no child in the outermost node is also known as leaf node. As we can see in the below figure, this is a root node, and these are the child nodes of this root node. And as there are no child nodes to this child node, it can be called as a leaf. The root of the tree is on top. The tree consists of nodes. Its connections are called as edges. The bottom nodes are also known as leaf nodes, as said in the previous slide. A tree may not have a cycle. For example, let us see the below figure. Here, we can see there are 8 nodes, and there is a root node 5. Here, this 5 is a root node, and these 3 and 8 are the child of 3 and 5. And 3 has again more 2 childs, and 8 has 2. And again, this has another child. This has no subordinate child. So this we can consider as a leaf, and this are considered as leaves. Binary node consists of the following components: data pointed to the left child and pointed to the right child. Here we can see this node consists of data, right child pointer, and left child pointer. This left child pointer points the address of the other child. Here we can see this having under same repeating condition: data pointed to the left child and pointed to the right child. As we can see, there is no right child for this child. We are having only left child. It is having only one box, and this is a leaf node. So same goes with this, but these have right and left pointers. Let us discuss about implementing for a binary tree. Defining a node class. The class node defines the structure of the node. Here we are taking a class node and defining a structure. Here we are defining the left data child, right data child, and the node data. Initializing the binary tree. We are defining a class node, and we are defining the left, right, and the data. Let us take the root as node 10. We are initializing the tree here in this step. For now, the tree has no childs. As we can see here, 10 has no child. As assigning the left and right childs as 34 and 89, for example, we are assigning the left child value as 34 and right child value as 89. Here we can see the tree has 2 more childs, 34 and 89. The trees are nonlinear data types multiple ways of reaching out to each an element or traversing elements. They can be listed out as in-order traversing, pre-order traversing, post-order traversing. In-order traversing. In the in-order traversing, the left child is visited first, followed by the parent and the right child. Let us take the example of this tree: 10, 34, 8, 9, 20, 45, 56, and 54. Here we can see the leftmost child is 20 is visited first, then followed by 34. Again, here we are not reaching out to the parent as it is visited last. We are going for the 45 and we are going for 10. Here, the 56, 89, 54 are last as they are the right childs. The pre-order traversing, the root node is visited first. Later, the left and right child are visited. Here we can see same 10, 34, 8, 9, 20, same root, same tree. And the pre-order traversal, the parent is visited first, the root is visited first, or the parent is visited first, followed by the left child and followed by the right child. Post-order traversing. The left child is visited first, followed by the right child, and followed by the root node in the pre-order traversing, post-order traversing. 20, 45, 34 is a right 20, 45, 34, 56, 54, 8, 9, and 10. Applications of a tree structured programs. We can manipulate hierarchical data. We can make information easy to search. We can manipulate sorted lists of data. Router algorithms can be made using the tree structured programs. A form of multi-stage decision making, such as games or etc., can be performed using the tree structured programs. As a workflow for composing digital images for visual effects, it is also used to represent computer file systems. Networks to find best path in the internet. Is used as an operating system, may use a tree for directories, files, and folders in its file management system. One reason to use trees might be because you want to store information in the natural forms of a hierarchy. As discussed in the previous slide, the file system on a computer. Here we can see first there is a root node. There will be a root node. We can access from a home, its child. From this home, we can access any child of it as courses or any upgrade or etc. Again, these courses may have multiple childs which you can select. These can form a simple menu and computer file system accessing. Thank you. This is Sudeshama signing off.